Hey guys, today we're going to talk about distance time graphs. Just a little disclaimer, I'm making this video in the car on the way to the state fair, and so it might be a little bit noisy and a baby might wake up and start crying, but we're just going to roll with it. So, describing the motion of an object is occasionally hard to do with words. Sometimes graphs help make motion easier to picture and therefore understand. Plotting distance against time can tell you a lot about motion. First, look at the axes. Time is always plotted on the x-axis, which is at the bottom of the graph. The further to the right on the axis, the longer the time from the start. Distance is plotted on the y-axis. The higher up the graph we go, the further we're getting away from the start. So let's look at 3 examples. In the first example, we have a straight diagonal line. Whenever we're looking at speed, we're going to be describing the slope of the line on a distance time graph to be able to determine what's actually happening. So graph 1 matches description B. The car is traveling at a constant speed because the slope is constant. Speed is just distance over time. And so just like in math class when you guys talked about slope, it's a change in y over a change in x. And so if our distance that we're going doesn't change in the interval of time, the slope is constant, therefore the speed is constant. In graph number 2, we have a straight horizontal line. That means that as time moves on, our distance isn't changing. And so this would best be described by A. The car is stopped because the slope is 0. Which leaves us with graph number 3, matches description C. The speed of the car is decreasing. If the speed is changing, the slope is changing. So in graph 3, we see that the slope here, we started out going faster and then we start to get slower. And so we see this curve in our slope here. So graph 3 matches description C because the slope is changing. So let's look at another example here. It says match the part of the graph to the description. So which one of these do you think would describe when an object was stationary? If you chose C, you are correct. Because there is no change in the slope here, there's no slope at all. Slope equals 0. This object is not moving. If we're seeing an increasing speed, we're seeing a change in speed, which means we need to see a change in slope. So which part would have a changing slope? If you chose D, that is correct. Number 6, a slow and constant speed. When we're looking at analyzing the speed of an object, the steepness of the slope is going to tell us a lot about if it's going fast or slow here. The steeper the slope, the faster the motion, because we're traveling more distance in the same amount of time. So for instance, let's look at segment A and segment B. In segment A, let's give these values. We'll just go by 1 because, that's easy. And we'll say our time is in minutes and our distance is in meters. So for A, in 3 minutes, it traveled 7 meters. But for B, in 3 minutes, it only traveled about 2.5 meters. So if we're looking for a slow and constant speed, that would be segment B because it has a gradual slope. And then A would be our fast and constant speed because it has a steep slope. Now, this one is where it gets a little bit tricky. We're left with E, but we want to talk about what this means here. So this on our graph is our start. And this object is moving away from the start. It stops, and then it comes back towards where it began. This is showing the actual position of an object, where it's actually traveling, and so we're showing the direction that it's moving here. So it's moving at the same speed as it did at B, but it's moving in the opposite direction. It's coming back towards the start here. So to summarize this, the steeper the graph, the faster the motion. A horizontal line means the object is not moving, it's stationary. And a curved line means the speed is changing by speeding up or slowing down. We call this change in motion is acceleration. Okay, so let's look at another example together. Turn off all these layers and turn on these ones. Cool. So it says, use the following paragraph and graph to answer questions 1 through 6. So you're going to complete this as part of your homework for this week, and you need to make sure that you have shown this to me before, or Miss Dexter, before Friday. So it says, on Saturday, Erin rode her bicycle to visit Caroline. Caroline's house is directly east of Erin's. The graph shows how far Erin was from her house after each minute of her trip. So we have time is in minutes and our distance is in meters. Erin rode at a constant speed for the first 4 minutes of her trip. What was her constant speed? So I'm not actually going to answer these questions for you. I'm just going to give you some helpful information to be able to solve them on your own. So number 1, Erin rode at a constant speed for the first 4 minutes of her trip. So it says here we're looking at this segment of her trip. What was her constant speed? So we know that speed is distance divided by time. And it gives us the time. So we know the time was 4 minutes. And so you need to be able to figure out what was our distance traveled divided by our time to solve this problem. Now for number 2, it says, what was Erin's average speed for the entire trip? Average speed equals the total distance traveled divided by the total time it takes. So for instance, right now I'm in the car on the way to the state fair. My maps is telling me that it's going to take us 2 hours and 20 minutes to get there.
Watch out, vehicle stopped on
But that's not
ahead.
accounting for any of the times that we stop for snacks or we stop for gas or any of those sorts of things. And so I have to look at what was the total time it takes. I might be in the car driving for 2 hours and 20 minutes, but part of that time might be spent doing other stuff, and so our whole trip might actually be like 3 hours. So when we're looking for the average speed, we have to account for all of the time it takes from the time we left our house to the time that we get there.
35 north.
So looking at this example, we have our start and we have our end, and we need to look at how far did we travel and how long did it take us to get there total. Now number 3 says, what was her average velocity for the entire trip? There is a key word in the paragraph that you need to identify for velocity. And if we remember, the difference between speed and velocity is that velocity has to have direction.
Stay to the left to I-35 north.
Number 4 says, Erin stopped to talk to another friend during her trip. How far was she from her house when she stopped? So we just talked about when an object is stationary, the slope will equal 0. So use this information to identify where was she when she stopped to talk to her friend.
Continue straight for 1 hour and 22 minutes to I-35 west north Fort Worth.
And this information I just gave you is really going to help you with number 5. Now number 6, it says, how is the slope of the line related to her speed? This question, I would like for you to summarize what we see happen to the slope of on a graph when it changes speed, when it is not moving, or when it's moving at a constant speed. So if you'll summarize for me what happens that you can see on a graph to analyze the motion of an object.
Watch out, vehicle stopped on shoulder ahead.
And then this last part here, vocabulary practice. An object is in motion when its distance from a position is changing. All right, position could be the start, it could be another object, it could be point A to point B. There's a bunch of different ways that you could say this, but it's just when its distance from where it started is changing. Speed in a given direction is velocity. And what can be calculated if you know the distance an object travels in 1 unit of time? That's speed. That is the definition of speed. Alright guys, so make sure that you finish questions 1 through 6 and that you show them to me by Friday for credit for your homework this week. Thanks.